Let's look at quadratic functions. What are quadratic functions and how is their shape looking like? Now let's start with the general equation for quadratic function, which is y is equals to ax squared plus q. Now this will help us to easily identify any other equation, whether it is a quadratic function or not. Let's take note that when we were doing linear equations, mx plus c was a linear equation function. Now, when you look at x, it had a variable 1, which indicated the linear equation shape and how it looked like, which is generally a straight line. Now, let's look at the difference now. In the quadratic equation, the first thing you notice that we had a 2 here, which means you have the x multiplied by x, giving you x squared. Now, that's the first feature which is important for us to be able to easily and first time identify whether this is a quadratic equation or not. Now, let's go back to additional features and also a shape of how this will look like. Now, of key importance is that firstly, you will have your a. In this instance, it's a 2 on our real equation with numbers. Then you have a q, which is a 6. Now, what this means is that when you see a first number being a positive, you must always know it's going to give us a happy parabola in this shape, which is facing up or opened up. And when you look at the last number, 6, you must know that in our graph, you will have a y being a 6 here, positive, so the graph will be curving this way, and it is a positive. So those two features, the 6 and the positive number here, they will give you the shape of a positive smile and also a point of x, which says you must move the graph up by this particular number, which is 6 in this instant. Now let's look at a next example, which also give us more features about identifying a parabola. Now, looking at what we have done before, we said, looking at the first number, that first number is going to demonstrate to us whether you have a happy or sad face. Now, it's a minus in this instance, but it's also a squared, which makes it quadratic. So let's look at what it will look like. So it's because it's a minus, you're going to have a sad face. So it's a graph facing down. And then you have your number here being positive 4, meaning that a 4, the graph is going to go from 0, 4 up, which is positive 4, but the graph will be facing down because it's a negative graph. And of course, it is a quadratic because it is x squared. So that is how then you would easily identify the shape of the graph by just looking at those two important features. Now, what happens in this particular instant? Now, to start with, you wouldn't jump straight into the features that we just spoken about. Why? Because it's not yet in a standard form of a quadratic function. Remember, our standard form was saying y is equals to a x squared plus q. So this is the format we're looking for, where y does not have any constant except 1, the imaginary 1. So this is the format that we want. Therefore, if you divide everything by 2, you will have y is equals to 2x squared plus 3. Okay, then you can go ahead and use the features that you see here that we always use to know the shape. Firstly, it's a plus, and also it's a squared, we know it's a quadratic, and then lastly there's a 3. Therefore, we are expecting a happy face because it's a plus 2. And then also, next important feature is that we are going to have our graph moving up by 3. So it has moved up by positive 3, which is somewhere down here. So it's how the shape it will look like. But of very key importance is what does it mean if you have a 2 here number? This is of significance just to understand the feature of what it means. Now, the smaller the number you have here, let's say it becomes 1 and so on, it means that the wider the graph will be. So the bigger the number becomes 4, 5, 6, and so on, then it means the less wider the graph will be, just like the less in terms of the final graph that you'll be having. So that's basically how would you interpret the number that is in front here. But in many cases, it won't be featured as part of your assessment and so on. It's just to understand how the features work as you do more advanced quadratic functions. So that will be then your features when it comes to quadratic equations, and also identifying the shape of a parabola shape. Let's look at finding the x-intercept. Now, to start with, we already can identify with the equation that it is a quadratic equation, because you can see that your greatest exponent on your variable is to the power 2, which is x squared. So that tells us already that you're dealing with a quadratic equation. Those got 3 terms, but we know that we are dealing with a quadratic equation. Now, the next step will be, if you look at your graph, and at any time they're saying x-intercept. X-intercept is represented by this horizontal graph, which definitely passes y. This is y. This is x all the time at 0. So x-intercept intercept the y line at 0. So what that means then is that we will have to take our equation and make it to be equal to 0, because that's where y is 0. So it will change shape and look like this, where it's x squared plus 3x plus 2, then that will give us 0, because we now know that y must be a 0, because that's where the x-intercept is. Now, when we therefore factorize this, we will get this being equals to 0, that is x, and then that is 2, that is 1, and then that is plus, and then what we'll eventually find is that when we continue, is that x plus 2 is equal to 0, or x plus 1 is equal to 0. So which eventually will give us x is equal to minus 2, or x is equal to minus 1. So this will then be our values where there is x-intercept and y is 0. And this is how then you find those particular 2 points, so that you can plot them on the graph. Now let's look at how the graph then will look like with these particular 2 values. Now just use the same space. We now have our values being minus 2 and minus 1. Now if it will represent only in our graph, then we know that our graph will look something like this, where we know for sure that this value and this value are definitely going to be minus 2 and minus 1. But then if you look at it, the Cartesian plane, all the minuses are this side, which therefore means that in our graph, you'll have the values appearing on the minus side. Okay, so typically you'll have a graph going this way. Okay, where you have your x, where you have your x value being -2 and your other x value also being -1. Okay, and this point will be -1, and then the second intercept will be -2. Okay, so that is what you'll find then in terms of the finding of x-intercept and also how you'll plot it. Now let's look at how will you then find the y-intercept. The y-intercept, same principle is that you would have your x being made 0, because again, if you look at the Cartesian plan with a 0 point of origin, you'll have your y here, you'll have your x. Now, what will happen then is that you will have where y is equals to 0 is this point, but where x is 0 is also this point. So meaning that you will have to have your x been made a 0 for you to get a y. So what that means is that in our equation, you will have x been replaced by 0 minus 9, which eventually will give us -9. Okay, so therefore you would mean our graph will move down, and since it's a positive here, from what we learned, we know that it will be a happy face. So you will have a happy face, but it will move down to a -9 somewhere down there. Okay, you'll typically have a graph that moves this way. Okay, because of your x-intercept, which is exactly at 0 here, point of origin. So this is how then you would then calculate your y-intercept in terms of the quadratic equation being given and the quadratic function being given.